In this short little video, we are going to look at two examples of finding the difference quotient. Now, the difference quotient is a concept that for some in algebra can be irritatingly complicated. However, as long as you kind of get the gist or the understanding of the formula and the basics behind what it is that you're doing, it's just a simplification of an algebraic problem. So what we have to remember is what the actual formula is. So when we're looking at difference quotient, we are looking at f of x plus h minus f of x all over h. Okay, so that is the formula we're using. Now what happens is in our problems we give you the f of x. What you don't have is x plus h, and so what you have to do is you have to first create the f of x plus h, and the way we do that is by evaluating. So we say, okay, I have the function as x plus h, and so that means anywhere you see the x, we need to plug in this x plus h thing. So here we're going to have 4 minus, and it's going to be x plus h squared. So we have to actually expand this out. So this is going to be 4 minus, and we're going to square this. This becomes x squared plus 2xh plus h squared. We have to distribute the negative. So this is the piece right here that gets distributed through that parentheses, essentially changing all of our signs. And so here this is going to become 4 minus x squared minus 2xh minus h squared. Now since there's no other simplification that I can actually do, I'm ready to plug my information into my difference quotient and then reduce from there to see what I actually have. So again, the difference quotient starts out by saying f of x plus h minus the f of x, and the whole thing is divided by h. So we have f of x plus h is going to be this piece right here. So we plug that in first. So this is 4 minus x squared minus 2xh minus h squared. So this is my first piece, and we're going to subtract that away from f of x. Well, f of x is the part that was given. So this is going to be subtracting out 4 minus x squared. And the whole thing is over h. So once you plug everything in, all you have to do is simplify. The first thing you would want to do is you want to take this and distribute it through your back parentheses, thus being able to drop both sets of parentheses here. So we have 4 minus x squared minus 2xh minus h squared minus 4 plus x squared. The whole thing is over h. Now your goal is that you want to get rid of all of your constants and your x only terms. So if we go ahead and take a look, I have positive 4 and negative 4, so these would go away. And then I have negative x squared and positive x squared, so these would go away. Now if you look at what's left, the only thing that's left are h terms. So here I have negative 2xh minus h squared all over h. So in this case, the first thing that you would do is we would go ahead and cancel. So if we look, I have an h, I have two h's and an h. So my h here on the top is going to go away. One of my h's over here is going to go away. So whenever what I tell students is cross out the power, don't cross out the variable, because one of these h's still stays and the h on the bottom goes away. Now if doing it like this is confusing, the other way that you could have looked at it is that on the top you had to pull an h out. That leaves behind the negative 2x minus h. The whole thing is over h. So my h's cross out. Okay, so however you're more comfortable canceling out your terms is what you wanted to do there. So this is going to leave us with negative 2x minus h, and this is your difference quotient. Now, it may seem a little awkward because I have my two variables here, but the difference quotient actually leads you into pre-calculus concepts which are not going to be gone over when we're just talking about the difference quotient. Okay, so this is kind of the groundwork that would lead you to some pre-calc or calculus ideas when you take the limit of things and evaluate at your infinities. But up until then, you just simply need to know how to actually find that difference quotient. All right, let's look at one more example here. This one is everybody's favorite, obviously. It is a fraction. So we have 1 over 2x. So we are going to go ahead and work with that. So in this case, I again have to start with finding x plus h. So here this would end up being 1 over 2 times x plus h, which we would need to simplify into 1 over 2x plus 2h. Once we find that, just like before, you plug it into your formula. So here we're going to have 1 over 2x plus 2h. We're going to subtract out 1 over 2x, and the whole thing is over h. So here what we are working with in your top the rules of fractions, which say you need a L least common denominator to add or subtract. So with this, we gotta take a quick minute and we have to kind of work numerator here. So I have 2x plus h and I have a 2x. So if I look at these two, my least common denominator is going to be 2x times 2x plus 2h. So when I look at my first fraction here, the piece that's missing is the 2x piece. So this is going to become 2x. The whole thing is going to be over that least common denominator, 2x times 2x plus 2h. And in my second fraction here, I'm missing the 2x plus 2h piece. So we're going to subtract, and what we're going to subtract out is going to be the 2x plus 2h, and of course the whole thing is still over h. Still working with simplifying that numerator, the first thing we need to do is take this negative, distribute it through, so we end up getting 2x minus 2x minus 2h all over the 2x times 2x plus 2h. The whole thing is still over h. Seems confusing, but let's keep going. One thing you should notice is that my 2x's disappear. Now the other piece we have to keep in mind is that we have a fraction rule which says you are going to multiply by the reciprocal of the denominator. So we're going to go ahead and rewrite this into a multiplication problem. So we have negative 2h over 2x times the 2x plus 2h, and we're going to multiply this by 1 over h. My h's top to bottom cancel and leaves me with negative 2 over the 2x times 2x plus 2h. But then we can also look at, can I cancel this down any further? And in this case, you can, because here I've got a 2 on the bottom, I have a 2 on top. So my final result is going to be negative 1 over x times 2x plus 2h. And from there you kind of have a couple things you could do. You can leave this as is. You could distribute the x through the bottom if you want to, but that's not really necessary. We also could have pulled the 2 out and put it on the outside, but again, like I said, that's not necessarily necessary. And so here, there you have it, another example of your difference quotient. So I hope these two different examples help you along with the work that you're trying to do. If you have any questions over them or any part that you are confused about, please don't hesitate to let me know. If you have an example or a difference quotient you're trying really hard to solve out for yourself and you're stuck, let me know that too. I would be more than happy to take some time and try and help you out. Otherwise, I do hope you enjoyed yourself as much as I did, and I will see you next time.